Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter some basic concepts of chemistry. So any doubts if you have in any steps, then please write that in the comment section. Mm, we shall obviously clarify them in the subsequent videos. Um, and also if you have more difficulty in any other chapter of chemistry, then also mention the name of that chapter in the comment section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter of chemistry will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told that the amount of heat evolved when 500 centimeter cube of zero point 0.1 molar HCl is mixed with 200 centimeter cube of zero point 0.2 molar NaOH. So the rule is that when 1 mole of H plus ion the rule is when 1 mole of H plus ion reacts means neutralizes 1 mole of hydroxyl ions, then H2O is formed and the amount of heat evolved, that is the enthalpy, that is equal to minus 57.1 kilojoule per mole. It is the amount of heat that is evolved per mole. So here it is told HCl is mixed with NaOH. So it means the here it is told 0.5 l- liter of 0.1 molar HCl, and here NaOH taken is 0.2 liter of 0.2 molar NaOH. So here the number of moles of HCl, that is 0.05 moles of HCl, and here 0.04 moles of NaOH is taken. So it means that 0.04 moles of HCl will react with 0.04 mole of NaOH. Means NaOH is the limiting reagent here. Limiting reagent. It means that the full amount of HCl will not react. So 0.01 mole will be remaining. It will remain unreacted. Will remain unreacted, and 0.04 mole will react. So 0.04 mole of H plus is neutralized by 0.04 mole of hydroxyl ion. So therefore, the amount of heat evolved that is equal to 0.04 into 57.1 kilojoule. That will be equal to 4 ones are 4, 4 sevens are 28, 4 fives are 20. So it will be 2.284 kilojoule. So which is close to 2.292, I can say. So option A is the correct answer. Okay. So here it is told a mixture of CaCl2 and NaCl weighing 4.44 gram is treated with sodium carbonate solution to precipitate all the Ca2 plus ions as calcium carbonate. The calcium carbonate so obtained is heated strongly to get 0.56 gram of calcium oxide. The percentage of NaCl in the mixture. The percentage of NaCl in the mixture. Okay, so then mixture of CaCl2 and NaCl in 4.44 gram is treated with sodium carbonate solution. CaCl2 is treated with sodium carbonate to form NaCl into CO3 to NaCl plus CaCO3. The percentage of NaCl in the mixture. So here we have a mixture of NaCl and NaCl plus CaCl2. So here let's say we have X gram of NaCl, and so the net weight of the mixture is 4.44 grams. So the amount of CaCl2 is 4.44 gram minus X, 4.44 minus X gram of CaCl2. So all the CH2 plus ions is precipitated. Now this CaCO3 is strongly heated to obtain calcium oxide plus CO2, and 0.56 gram of calcium oxide is obtained. So here we know that 1 mole of calcium carbonate will liberate 1 mole of CaO. So now molar mass of calcium oxide, that is equal to 40 plus 16, that is 56 gram of this. So 0.56 gram means 0.01 mole. So 0.01 mole of calcium oxide will be obtained from 0.01 mole of calcium carbonate. Now 0.01 mole of calcium carbonate is obtained from 0.01 mole of calcium chloride. So therefore, molar mass of calcium chloride, that is equal to 40 plus 71. So that will be 111 gram. Now therefore, the mass of CaCl2 that is present in the mixture, that is equal to 0.01 moles into 111 gram, that is equal to 1.11 gram. So therefore, this mass of CaCl2 we know that is equal to 4.44 minus X. So 4.44 minus X is 1.11 gram. So therefore the X will be equal to 3.33 gram. So therefore the mass of NaCl that is present in the mixture is 3.33 gram. Now therefore the here it is asked to find the percentage of NaCl in the mixture. Percentage of NaCl present, that is the mass of NaCl that is present, mass of NaCl that is present in the mixture divided by the mass of the mixture, means the total mass of the mixture into 100%. So that will be 3.33 gram divided by 4.44 gram into 100%. So if we can remove the point, and then we can cancel out by 111. 111 into 3 is 33. 111 into 4 is 444. So 34 into 100, so 425 is 100, so 3 into 25 is 75%. So 75% is the percentage of NaCl in the mixture. So option A is the correct answer. Then here it is told 50 centimeter cube of 0.2 normal HCl is titrated against 0.1 normal NaOH solution. 50 centimeter cube of 0.2 normal HCl is titrated with NaOH solution. So here the titration is discontinued after adding 50 centimeter cube of NaOH. So the remaining titration is completed by adding 0.5 normal KOH, the volume of KOH required for completing the titration. It means here the number of millimoles of HCl that is present here, that is, so we know that when there is complete neutralization, then the number of milliequivalents of the acid, the number of milliequivalents of the acid should be equal to the number of milliequivalents of the base. Now, the number of milliequivalents is equal to the normality into the volume. Normality times the volume. Now, um, the number of milliequivalents of the acid, that will be equal to 0.2 normal into the 50 centimeter cubes of 50 ml. So that will be equal to 10 millimoles. 10 millimoles. Then here the number of milliequivalents of the NaOH that is taken, that is 50 ml, 50 into, so here I can say it is 50 milliequivalents actually, milliequivalents, and here of course the number of milliequivalents will be equal to the number of millimoles only. Since why here the valency factor for NaOH is same as 1 only. Valency, here the valency factor of KOH is also 1 and the valency factor of HCl is also 1 only. So here the number of milliequivalents is same as the number of millimoles. Milliequivalents is same as the number of millimoles. Now here 50 ml into 0.1 normal, that is 5 milli equivalent. 5 milli equivalent, 5 millimoles. So which is same as 5 millimoles. So here for HCl we have 10 millimoles. So it means here 5 millimole of HCl will remain unreacted and that will react with, that should react with 5 millimoles of KOH. So therefore here this 5 millimoles that should be equal to the normality of KOH, which is 0.5 normal into the volume of KOH in centimeter cube. Now therefore V will be equal to 5 by 0.5, so that is equal to 10 centimeter cube. So 10 centimeter cube of KOH is required for completing the titration. So option B is the correct answer. And then here it is told, in which of the following does the given amount of chlorine exert the does the given amount of chlorine exert the least? Okay. In which one of the following does the given amount of chlorine exert the least pressure in a vessel of capacity vessel of capacity 1 decimeter cube means 1 liter I can say at 273 Kelvin. So the pressure should be the least. The given amount of chlorine. So here chlorine gas is present. Chlorine gas. So and we have to consider it as ideal gas. We have to assume it as ideal gas only. So now we know that pressure is given as nRT by V, T by V, and the volume has been given, temperature is given, and we have to find the number of moles. So here the temperature and the volume is the same only. So therefore I can say the pressure will be proportional to the number of moles, since here the volume and temperature are kept constant. V and T are kept constant. So now for the first option, we know that so the number of moles of chlorine in the first case, that is 0.0355 gram, the given mass divided by molar mass, which is 35.5 into 2, 35.5 into 2 gram, is 71 grams. So this will be, this I can write 35.5 into 10 power minus 3 gram divided by 35.5 into 2 gram. Okay, gram will cancel, 35.5 will cancel. So 1 by 2, so it is 5 into 10 power minus 4 moles. And the second one, that is B, so here the number of moles of chlorine, that is equal to 0.071 gram divided by 71 gram. So that is 0.001 mole, that is 10 power minus 3 mole. And in the C option, is told 6.023 to 10 power 21 molecules. So number of moles, we can say the given number of molecules divided by the Avogadro number. So this divided by 6.023 into 10 power 23. So that will be equal to 6.023 will cancel. That is 10 power 21 minus 23. That is 10 power minus 2 moles. And in the D option, that is 0.02 mole. That is 2 into 10 power minus 2 mole. So it means here it is asked that which will exert the least pressure. So if the number of moles is the least, then only the pressure exerted will be the least. Since we have seen that the exerted pressure on the vessel, that is proportional to the number of moles of the ideal gas. So the number of moles is the least only in the first option. So option A is the correct answer. Then here it is told 1 gram of silver gets distributed 1 gram of silver gets distributed between 10 centimeter cube of molten zinc, 10 centimeter cube of 10 centimeter cube of molten zinc, and 100 centimeter cube of molten lead at 800 degrees Celsius. Then the the percentage of silver in the zinc layer is approximately. So Actually, there is something called as partition coefficient. Partition coefficient. So it is given as the ratio of the concentration. So partition coefficient of silver is given as the concentration of silver concentration of silver in the molten zinc divided by the concentration of silver in molten lead molten lead at 800 degrees Celsius. So here we uh, then the partition coefficient of silver, that is equal to 300 at 800 degree Celsius. At 800 degrees Celsius, the partition coefficient of silver is 300. So now here it is asked to find the percentage of silver in the zinc layer. Percentage of silver in the zinc layer. Now it means that so here it has been told that so so now the partition coefficient of silver is 300 at 800 degrees Celsius, and here it is told 1 gram of silver is distributed. So here we have molten zinc and molten lead, and this 1 gram of silver is distributed among zinc and silver, zinc and lead. So 1 gram of silver, out of 1 gram of silver, let's say X gram of silver is is distributed with zinc, and the remaining amount, which is 1 minus X gram, is distributed among lead. So therefore, the concentration of silver in lead in zinc, that is equal to X gram divided by 10 ml. So it is uh, gram per ml. X by 10 gram per ml concentration of silver. Then the concentration of silver in lead, that will be equal to 1 minus X by 100 gram per ml. Since by 1 ml, I can say 1 centimeter cube. So the volume of the molten zinc, that is given as 10 ml, and the volume of molten lead is given 100 ml. So now, therefore, the partition coefficient, that is 300, that is equal to X by 10 divided by 1 minus X by 100, which is the concentration of silver in zinc by concentration of silver in lead. So therefore, if we solve it, then we will get 1 minus x by 100 into 300, that is equal to x by 10. Now this is 30 minus 30x, that is equal to x. So therefore 31x, that is equal to 30, x equal to 30 by 31. Now therefore the percentage of silver in the zinc layer, that will be equal to x gram divided by 1 gram into 100%. Since why the total mass of silver that is distributed, that was 1 gram, and then the mass of the zinc, the mass of the silver that is kept in the zinc layer, that is x gram. So that is x into 100, that is 30 by 31 into 100%. So if we solve it, then we will get approximately 97%. So it means option C is the correct answer. And here it is told 1 gram of silver gets distributed between 10 centimeter cube of molten zinc and 100 centimeter cube of molten lead at 800 degrees Celsius. The percentage of silver still left in the lead layer is approximately. So here we saw that the the partition coefficient of silver, the partition coefficient of silver is given as the concentration of silver in zinc divided by the concentration of silver in lead. And at 800 degrees Celsius, the partition coefficient of silver is given as partition coefficient of silver is given as 300. So now therefore so here 1 gram of silver is distributed in between the molten zinc and molten lead, and the molten zinc is 10 centimeter cube. The volume of the molten zinc is 10 centimeter cube, or 10 ml, and the volume of the molten lead is 100 centimeter cube or 100 ml. So let's say out of this 1 gram, x gram is mixed with zinc, and the remaining, which is 1 minus x gram, is mixed with the molten lead. So therefore the partition coefficient is 300. Therefore we have to find the concentration of silver in zinc, that is equal to x by 10 gram per ml. Similarly, concentration, so here we are giving the concentration in the unit gram per ml, and the concentration of silver in lead, that is equal to 1 minus x by 100 gram per ml. So now therefore here we have to find the percentage of silver in the lead layer. Now that will be equal to the concentration of silver in means the mass of silver in the lead layer, which is 1 minus x, divided by the total mass of silver which is taken, which is 1 gram, into 100%. So it means we have to do 1 minus x into 100%. That will give us the answer. Now therefore we can say that 300, that is the partition coefficient, that is the concentration of silver in zinc by concentration of silver in lead. So this, if we solve it, then we will get 1 minus x by 100 into 300, that is equal to x by 10. So therefore we can say 30 into 1 minus x, that is equal to x. Therefore x will be equal to 30 by 31. Therefore 1 minus x, that will be equal to 1 minus 30 by 31, that is equal to 1 by 31. So the percentage of silver that is remaining or left in the lead layer, left in the lead layer, that is equal to 1 minus x by 1 into 100%. So that will be equal to 1 minus x, which is equal to 1 by 31 into 100%, so which is approximately equal to 3%. So option C is the correct answer. Then here it is told excess of silver nitrate solution is added. Excess of silver nitrate solution is added to 100 ml of 0.01 molar penta aqua chromium chloride. Penta aqua chromium chloride. So which formula is like this: Cr penta aqua. So H2O 5 chloro, then chloride. It will be Cl2. So now this is called as this penta aqua penta aqua chromium 3 chloride. So excess of silver nitrate solution is added to 100 ml of 0.01 molar penta-aqua-chlorochromium chloride. Then here the mass of silver chloride that is obtained in grams is. So here it will react with this, then it will form 2 AgCl. It will form 2 AgCl. Now silver chloride is a white colored precipitate. White precipitate will be formed. Then plus it will form chromium penta-aqua, chromium penta-aqua chloro, chromium penta-aqua chloro nitrate, 3 whole twice. This will be formed. So now here, as you see that 1 mole of this penta-aqua-chlorochromium chloride, 1 mole of penta-aqua-chlorochromium chloride gives 2 moles of silver chloride. So it means here we have taken 100 ml of 0.01 molar of penta-aqua chlorochromium chloride. So therefore, the number of moles of AgCl that will be obtained, that is equal to twice of the number of moles of this penta-aqua chlorochromium chloride. Okay. So therefore, the number of moles of penta-aqua chlorochromium chloride, that is equal to 0.1 liter into 0.01 molar, so which will be equal to 0.001 moles. So it means the number of moles of AgCl produced will be 0.002 moles. Now the atomic mass of silver is 108. Therefore, we have to find the mass of silver chloride that is obtained. Now, therefore, the mass of silver chloride that is obtained, that is equal to the number of moles, that is 0.002, into the molar mass of silver chloride. Now, the molar mass of silver chloride, that will be equal to 108, the atomic mass of silver, plus the molar mass of silver is 108, and molar mass of chlorine, that is 35.5. So then we will have, uh, so this is 10 power minus 3, I can write, into 2 into 108 plus 35.5. So this will be equal to 10 power minus 3 into 2 into 108 is 216, plus this will be 71. So this is 287 into 10 power minus 3 grams. 10 power minus 3 grams. Okay. So it means that option A is the correct answer. Then here it is told the equivalent mass of a certain bivalent metal is 20. The molecular mass of its anhydrous chloride is. Now, so it is a metal, bivalent metal. So it is of the form M2 plus. Its ion is in the form of M2 plus ion. Now, the equivalent mass, as we know, equivalent mass, that is given as the atomic mass divided by the valency factor, or the n factor. Now here it is bivalent, so it means that its valency factor is 2. Now therefore the equivalent mass is given as 20. So 20 equals to the mass of atomic mass of this metal divided by valency factor, which is 2. Therefore the atomic mass of the bivalent metal, that is equal to 40. So the atomic mass of the metal is 40. Now therefore the molecular, so its molecular formula, or you can say the molecular formula of its anhydrous chloride, molecular formula of its anhydrous chloride will be like this. It will be MCl2. Now therefore the molecular mass molecular mass of this anhydrous chloride, that will be equal to the atomic mass of the metal M, that is 40, plus Cl2, which is 2 into 35.5. So that will be 40 plus 71, that is equal to 111 gram. So it means that option B is the correct answer. Then here it is told that 20 ml of methane is completely burnt using 50 ml of oxygen. So it will react with oxygen to give CO2 plus H2O plus some heat. Okay. So it will give one CO2 and H2O, it will be 2 H2O, and the number of oxygens will be 2. So here it is told 20 ml of CH4 is completely burnt using 50 ml of oxygen. 50 ml of oxygen. So the volume of the gas left after cooling to room temperature is. So we know that the volume is proportional to the number of moles n if the pressure and the temperature are kept constant. So in most of the reactions are carried out under the atmospheric pressure. Most reactions are carried out in an open container in and where atmospheric pressure is acting. So the atmospheric pressure is constant only. So it means all the reactions are carried out under constant pressure. So the pressure is also constant and the temperature is also constant. So now here, so it means the volume ratio will be same as the mole ratio. So it means 20 ml of CH4 will react with 40 ml of oxygen. So it means 10 ml of oxygen will remain. So here there is something wrong. Sorry, this will be O2. This is not 2. This will be CH4 plus O2 gives 2H2. Okay. No, CH4 plus O2 is 2. Okay, no, there it will be 2 only. Okay. So, okay. So it means 10 ml of oxygen gas will remain, and 20 ml of CO2 will be formed, and 40 ml of H2O gas also will be formed. 40 ml of H2O will be formed. So now, and H2O is in the liquid form. So now, therefore, the volume of the gases left, that is 10 ml of O2 gas will remain, and 20 ml of CO2 gas will be formed. CO2 gas will be formed. So therefore, the total volume of the gases which will be left, that will be 10 ml of O2 plus 20 ml of CO2 plus 20 ml of CO2. So it will be 30 ml. So option D is the correct answer. 30 ml of oxygen gas, 30 ml of the CO2 and O2 gas will remain. So option D is the correct answer. Then here it is told 100 ml of 0.1 molar acetic acid is completely neutralized using a standard solution of NaOH. The volume of ethane obtained at STP after the complete electrolysis of the resulting solution is. So acetic acid, CH3COH, it is completely neutralized using NaOH. So the volume of ethene, the volume of ethane obtained at STP after the complete electrolysis of the resultant solution. So from here CH3CONA, which is sodium acetate, will be obtained with H2O, and then this will be electrolyzed, and from here ethane will be obtained, So from 1 mole of sodium acetate is electrolyzed. So on the electrolysis of 1 mole of sodium acetate, 1 mole of ethane C2H6 will be obtained at STP. H3CONA will react with 2H2O to form C2H6 plus 2CO2 plus 2NOH plus H2. So here, from here you can see that 1 mole of acetic acid will produce, okay, or here we can write this is 1 mole. So then here half mole will be formed. Half mole of C2H6 plus plus CO2 plus NaOH plus H2. So then here, so it means 1 mole of acetic acid will produce 1 mole of sodium acetate, and which will pro produce half mole of ethane. Half mole of ethane. So here it is 100 ml of 0.1 molar of acetic acid has been taken. It means 0.1 liter of 0.1 molar. It means it is 0.01 moles. 0.01 mole of acetic acid is taken. Acetic acid is taken. So which will form 0.1 mole of sodium acetate, and which will form half of that, means 0.005 mole of ethane will be formed. Now, if we consider ethane as an ideal gas, suppose if we consider ethane as an ideal gas, then here we have to find the volume of ethane that is obtained at STP. So now, therefore, 1 mole of the ideal gas, which is ethane, that will occupy that will occupy um, 1 mole of ethane will occupy 22.4 liter, or I can say 22,400 milliliter ml of ethane. Now, therefore, 0.05 mole of ethane, 0.05 mole of ethane will occupy how much? 0.05 mole of ethane will occupy how much ml of ethane that has been asked. So that will be equal to 0.05 into 22400 ml of ethane. So that will be equal to 5 by 100 into 22400 ml of ethane. 0 will cancel. So 5 into this, so 5 fourths are 20. 5 is a 10. 2, 5 is a 10. 1, 120 ml. Sorry, this is 0.005 mole. 0.005. This is 5 by 1000. So this, we can say this by 10 again. It's by 10, so 112 ml. 112 ml of NaOH will be formed. No, 112 ml of ethane will be formed at STP. So option A is the correct answer. Then it is told the total number of electrons in 18 ml of water is. So we know that in one molecule in one molecule of water we have we have um, so hydrogen has one electron each, and oxygen has got uh, or and oxygen has got six electrons, means sorry, eight, six electrons in the outermost shell, so eight electrons it has overall. Overall, one second. So in one molecule of H2O, we have 2 plus 8, so 10 electrons. So 18 ml of water, the density is 1 gram per ml, means it is mass equals to volume into density. So it will be 18 gram of water. Now molar mass, molar mass of water is 16 plus 2, that is 18 gram. So here we have 1 mole of water. 1 mole of water molecules we are having. So it means that 1 mole of water molecules, it means we have Avogadro number of water molecules. So 6.02 into 10 power 23 molecules of water we are having. So will that will contain this much into 10. So 6.02 into 10 power 24 electrons. So these many electrons it will contain. So it means option C is the correct answer. Then here it is told that the number of moles of hydrogen that can be added to 1 mole of an oil in the highest in then here it is told that the number of moles of hydrogen that can be added to 1 mole of an oil is the highest in. So if the um, degree of unsaturation, if the degree of unsaturation is the highest, if the degree of unsaturation is highest, is high, if the degree of unsaturation is high, then only we can say then it means more number of moles, more number of hydrogen atoms can be added. More number of hydrogen atoms can be added to it. Now, out of all these oils, linseed oil, groundnut oil, sunflower seed oil, and mustard oil, the linseed oil has got the highest degree of unsaturation. Highest degree of unsaturation. Linseed oil has the highest degree of unsaturation. So in linseed oil only, the number of moles of hydrogen that can be added, number of moles of hydrogen that can be added is highest. It is highest in linseed oil. So option A is the correct answer. Then here it is told the volume of 0.1 molar oxalic acid that can be completely oxidized by 20 ml of 0.025 molar KMnO4 solution is. So oxalic acid means H2C2O4, H2C2O4, or we can write it C2O4, COOH whole twice. COOH whole twice we can also write. The structure of oxalic acid is like this only, COH, COH. This is called oxalic acid. So it is completely neutralized with, completely oxidized by when KMnO4 solution. So here, when KMnO4 is in the is in the acidic medium, then KMnO4 will change into Mn2 plus ion. Means it will form MnC2O4. It will form MnC2O4. Okay. So it is in the acidic medium. So here sulfuric acid is also added. Sulfuric acid H2SO4 plus 5H2C2O4 plus 2KMnO4 will give K2SO4 plus 2MnSO4 plus 10CO2 plus 8H2O. Or we can say it like this also, that in the acidic medium, KMnO4 will change into Mn2 plus ion. It means that MnO4 minus will change into Mn2 plus ion. So it means that its valency factor is 5. Since manganese ion Mn is changing from its oxidation state of +7 to +2, so it will gain 5 electrons. So it means its valency factor is 5 for KMnO4. And in the acidic medium, C2O4 2 minus ion, which is the oxalate ion that will change into CO2. So here the valency for, or the oxidation state of carbon, here it is. It will be 4 to the 8, 8, 6, so 6 by 2, that is 3. So it is +3, and here it is +4. So here it means that it will lose 2 electrons. So it means the valency factor of oxalic acid is 2. Since why it will lose 2 electrons. So now therefore, so actually here simply we don't need this balanced chemical equation. Simply we can solve it by using this valency factor. Since why we can simply apply the law of equivalence. Law of equivalence, which states that the number of equivalents, the number of, or I can say the number of milli equivalents of all the reactants and all the products should be same. So it means the number of milli equivalents of oxalic acid here, that should be oxalic acid, that should be equal to the milli equivalents number of milli equivalents of KMnO4. Now, therefore, the number of milli equivalents of oxalic acid, we can say the number of millimoles, the number of millimoles of oxalic acid into the valency factor of oxalic acid, which is 2. Valency factor of oxalic acid, that will be equal to the millimoles of millimoles of the KMnO4 times the valency factor of KMnO4. Now the valency factor of KMnO4 is 5 and the valency factor of oxalic acid is 2. Now the number of millimoles of KMnO4, how to find? The number of millimoles is given as the molarity of the solution into the volume in milliliter, the volume in ml. So that will give you the number of millimoles. So then here it is told the volume of 0.1 molar oxalic acid that is required. So let the volume of oxalic acid required. Oxalic acid needed be x ml. So therefore, the number of millimoles of oxalic acid, that will be equal to x into the 0.1 molar. That should, and that into the valency factor of oxalic acid, that is 2, and that will be equal to the number of millimoles of KMnO4, which is the molarity of KMnO4, which is 0.025 into the volume of KMnO4, that is 20 ml, into the valency factor of KMnO4, which is 5. Now if we solve it, then we will get x into 0.2, that is equal to 20 into 5, that is 100 into this, so that is 2.5. So x will be equal to 2.5 divided by 0.2, that will be equal to 25 by 2, that is 12.5 ml. So 12.5 ml of oxalic acid is required. So option C is the correct answer. Then here it is told the number of water molecules present in a drop of water weighing 0.018 gram is. So therefore, the number of moles of water molecules, that is equal to the given mass divided by molar mass of water. Now the molar mass of water, as we know, that is equal to uh, molar mass of hydrogen, means 2 gram plus 16 gram, that is 18 gram. Now the given mass is 0.018 gram divided by the molar mass of water, that is 18 grams. So that will be equal to 0.001 mole. So therefore, now the number of moles of water is 0.001 mole. Therefore, the number of moles of water that can, therefore the number of molecules of water that would be equal to number of molecules of water, that would be equal to the number of moles of water times the Avogadro number. So that is 0.001 moles into Avogadro number, that is 6.022 into 10 power 23. So that is equal to 6.022. This I can write 10 power minus 3. So it is 6.022 into 10 power 20 molecules. So option D is the correct answer. Then here it is told empirical formula of a compound is CH2O and its molecular mass is 90. Then the molecular formula of the compound is. Now therefore here we have to find out the value of N. N is equal to, so here N is equal to the molecular formula, the molecular mass by empirical formula mass, by empirical formula mass. Now, if we can find out N, then we can say the molecular formula of the compound that will be given as uh, the empirical formula times N. The empirical formula times or whole N. It means that it will come CH2O whole N, it will come. And then we can write it as CnH2nOn. So now we have to find out N. N is equal to the molecular mass that is given, that is 90, divided by empirical formula mass. Now empirical formula mass that will be given as uh, simply the mass of CH2O we have to find. So that will be 12 plus 2 plus for oxygen, that is 16. So 18 plus 12, that is 30. So N equals to 3. Therefore, the molecular formula is of the compound is CH2O whole 3. So that will be C3H6O3. So option A is the correct answer. Then here it is told the mass of 112 centimeter cube of NH3 gas at STP is. The mass of 112 centimeter cube of NH3 gas. Okay. So now at STP. So now we know that the volume occupied by 1 mole of any ideal gas. 1 mole of an ideal gas at STP. At STP is given as 22,400 ml. So now, therefore, the number of moles of NH3 here, that will be equal to the volume of NH3 that is occupied at STP divided by the molar volume at STP. So that will be equal to the volume occupied, that is 112 ml or 112 centimeter cube, same thing, since 1 centimeter cube is same as 1 ml only. So 112 ml divided by 22,400 ml. So ml will cancel, that will come 200, 1 by 200 mole, 1 by 200 mole. Now, therefore, the mass of this much volume, the mass will be equal to the number of moles of NH3 times the molar mass of NH3. Now, the molar mass of NH3, that will be equal to 14 plus 3 gram, that is 17 gram. So therefore, the mass of this given volume of NH3 gas at STP, that will be equal to 1 by 200 into 17, this much gram. So that will be equal to 2 8 is 16, 2 5 is 10, 8.5 divided by 100. So that will be equal to 8, no, sorry. Be 0.085 gram. So option A is the correct answer. Then here it is told that 50 centimeter cube of 0.04 molar K2Cr2O7 in acidic m- medium. So K2Cr2O7 in m- medium, acidic medium that oxidizes a sample of, it will oxidizes a sample of H2S gas to sulfur. So here it is chromium, it is in the 7 to the 14, 14 minus 2, so 12 by 2, that is 6. So here chromium is in +6 oxidation state, so that will oxidize H2S to sulfur. Here sulfur is in -2 oxidation state, here it is in 0 oxidation state, and it will form Cr3 plus ion, Cr3 plus. So here it will itself get reduced and it will oxidize sulfur. Now here the volume of 0.03 molar KMnO4 required to oxidize the same amount of H2S gas to sulfur in acidic medium is. So now here therefore the valency factor for H2S, valency factor for H2S, that is equal to 2, since why H2S has to lose 2 electrons. Since sulfur in the 2 minus oxidation state, that has to lose 2 electrons to have 0 oxidation state. And similarly, the valency factor for K2Cr2O7, K2Cr2O7, that will be equal to here Cr2O7 2 minus, that has to gain, that will form Cr3 plus ion, so 2 Cr3 plus ion, and so here it is in 6 plus, so it has to gain 6 electrons to form Cr3 plus ion. So here the valency factor for K2Cr2O7 is 6, and then when if we have KMnO4 in the acidic m- medium, it means we have MnO4 minus ion, and then it has to gain 5 electrons to form Mn2 plus ion in the acidic medium, the acidic medium. So therefore, the valency factor for K2 for KMnO4 in the acidic medium, that will be equal to 5. Now here the amount of K2Cr2O7 that is used, that is 50 centimeter cube or 50 ml of 0.04 molar. It means that we can say it is 100 by 2, so it will be 2 millimoles. 2 millimoles of K2Cr2O7 has been taken, and it oxidizes a sample of H2S gas to sulfur. So let's say the amount of H2S that is taken here is X, or I can say N millimoles, N millimoles. So now here again we can use the law of equivalence. So according to the law of equivalence, we can say that the number of milli equivalents, the number of milli equivalents of the H2S, that should be equal to the number of milli equivalents of the KMnO4 or K2Cr2O7, and when it reacts with KMnO4, then also the number of milli equivalents of H2S, which should be kept same, that should be equal to the number of milli equivalents of KMnO4. Since here same amount of H2S gas has been used, has been oxidized, the same amount of H2S gas has been oxidized to sulfur here. which will be same as the number of milli-equivalents of KMnO4. So now here the number of milli-equivalents of H2S, that is equal to the number of millimoles of H2S, or the or so yeah, the number of millimoles of H2S into the valency factor of H2S, which is 2, that should be equal to the number of millimoles of K2Cr2O7 into the valency factor of K2Cr2O7, which is 6. That should be equal to the number of millimoles of KMnO4 into the valency factor for KMnO4, which is 5. Now let's suppose we take let's suppose x ml of KMnO4 is required. KMnO4 is required to oxidize it. So x ml of 0.03 molar KMnO4 is required. So therefore, the number of millimoles of H2S, that is n, we have assumed. So n into 2, that will be equal to the number of millimoles of K2Cr2O7, which is 2 into 6, and that should be equal to the number of millimoles of KMnO4, which is x into 0.03 into 5. So n we don't have to find, we have to find x. So therefore, we can simply say 12 equals to 0.15, 3 5 is 15 into x. So therefore, x will be equal to 12 by 0.15, which is 12 by 15 into 100. So 3 4s are 12, 3 5s are 15, 5 2s are 20, so 80 ml. So 80 ml of 80 centimeter cube of KMnO4 is required to oxidize the same amount of H2S to sulfur in the acidic medium. So option B is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCET exam on the chapter basic concepts of chemistry. Still, any doubts if you have, please write that in the comments section. We shall obviously clarify them in the subsequent videos and in any other. And also please install our Sapience education application, since we shall upload some important homework questions on which are based on the previous year KCET exam. So thank you everyone. Bye.